Hello. So today let's discuss the welfare theory. Okay. So previously based on the preference-based approach, we discussed this is so-called the positive or behavioral perspective of economics, including the ones that we discussed, such as the utility maximization problem and the expenditure minimization problems. Okay. But there'll be another or alternative perspective called normative. Okay, and in normative perspectives, for example, we can have some welfare analysis to help us to further understand the other view or another aspect of economics analysis. Okay, so essentially, in welfare analysis, we simply evaluate the effects of the changes in the consumer's environment on the well-being. Okay, so what do we mean by this environment is sometimes we change the prices, right, or we change other things, but mostly we just change the prices as we see before. Okay, good. So that's the main topic of the welfare analysis. Okay, so we know that it should be okay to use the indirect utility, the V function, which is the value function derived from the UMP, to measure the welfare. Okay, but there'll be a problem of using this for the welfare analysis because this value from the utility will be still ordinal. Okay, and we have already mentioned that the ordinal measures they have some problems if you want to compare the differences between different measures of these v functions. Okay, so there will be some problems. So it might be better to have to construct some alternative metrics which are not ordinal but cardinal. Okay, so here there will be something very natural to use as the money metrics. So that will be our expenditure function. Okay, taking this V into this expenditure. Okay, so this E, it's representing the money, right? So, and then we can compare across different money expenditures, then to help us to measure the welfare changes. Okay, good. So, in a long time ago, Higgs, so that's the person in Higgs and demand, right? So Higgs in 1939 provided two very famous measures of the welfare changes. So one of those is called equivalent variation, EV, and another one was compensating variation, CV. Okay, so those are two variations. They are just some metrics, as we just said. Okay, some ways or approaches to compute the changes of the consumers' welfare, or in terms of the expenditures that we just said, right? In terms of the ease, and how to see how do we use those ease to calculate the differences between those welfare. Okay, those are just some two different ways, and sometimes they're equal to each other, and sometimes not, and under some certain situations. Okay, good. So let's formally define those two variations. So we still hold the same old assumptions as before, as in the previous episodes, and we'll just keep those assumptions. And here we suppose that this U naught. Okay, so whenever we use this superscript of 0 to denote the old values, okay, the old utilities or the old prices, U naught or P naught, or U0 or P0, and we use the ones such as U1 or P1 to denote the new ones. Okay, so the old ones were before the price change, and the new ones are after the price change. Okay, so this U0 will be just the indirect utility taking this P0 and W, and U1 will be corresponding the V of P1 and W. And we know that from the duality of the UMP and EMP, so we after spending all the money in the budget W, then the expenditure of no matter you are before the price change or after the price change, you always spend all the money that you have for this W. Okay, good. So the definition for EV, okay, so that'll be the difference of two expenditures. Okay, so here, those two expenditures, we are comparing across different level of utilities before and after the price change. Okay, so here, the important part for this EV would be such that we are always using the same old price. Okay, so that would be something important to notice. Okay, so here further we have this, and the other one will be just the W. Okay, so similarly we can define the CV. Okay, so CV, again, it is also some difference between expenditures, okay, among different utility levels. But here the something will be different from the definition of EV. So CV here, it takes both two expenditures, both of them, they're taking the new prices, which is P1. And the EV took the old prices, P0. So this will be the only difference between CV and EV. Okay. All right. So again, so this will be W and the other one will be the same. Okay. All right. So those are the definitions for EV and CV. Okay. So if you want to have further reading on the textbook, and you can refer to the corresponding section in the CV and EV and have some implications as written on the textbook for the definitions of those things. Okay, so in short, let's have a quick look on those explanations. So they said that the equivalent variation, so the EV, it can be thought of as the dollar amount that the consumer will be indifferent about accepting in the lieu of the price change. Okay, that is the change in the wealth that will be equivalent to the price change in terms of the welfare impact. Okay. And in contrast, the compensating variation, it measures the net revenue of a planner, so that's someone else who is planning the price, who must compensate the consumer for the price change after it occurs, bringing her back to her original utility level U0. Okay, so that's those are the explanations of CV and EV, but that was not very straightforward enough, right? So why not let's just take a look on the pictures, which might be helpful for us to understand those definitions. Okay, so now we are looking at the picture of EV. Okay, so we have this two-dimensional consumption space with X1 and X2, two commodities. And so before the price change, we have this budget. Okay, so in this budget, we have this. So we always fix the price for commodity 2. Okay, so we're not caring about anything for X2. So here we're referring to the P0 or P1 just for the prices for X1. Okay, so here in this initial price P0, this was the initial bundle, and after the price change, okay, so it looks like the price has dropped, right? So in this case, with the new price P1, we can buy more of X1. Okay, so what is EV asking is that we need to find the difference of the expenditures, okay, for this consumer, but we're comparing across different utilities. Okay, so we're comparing across, this will be the new utility level U1 and compared to the old utility level U0. But we're in both two expenditures, we're both using the old price P0. Okay, so we know that this was the old price, right? So how do we copy that old price to the new utility U1? Right, so that'll be the question here. So we simply shift that straight line and parallel to that, and we shift that to here. Okay, so this dotted line here, that'll be this new budget and containing the old price P0. Okay, so in this case, then we can find this consumption set, and then we can calculate this expenditure, which is containing this old price P0, and here we'll be using achieving this new utility U1. Okay, good. So then we can simply find those expenditures on the vertical axis. Okay, so this intersection here, this level will be simply the expenditure where we're having this P0 but U1. Okay, and this point, this intercept will be the level of the expenditure where we have this P0 but U0. Okay, and because we're having this x1 to be 0, and here this level will be simply the value divided by the P2. So if we normalize P2 to be 1, because P2 doesn't change, and if we normalize the old or new price, both of the old and new price of P2 to be 1, and this denominator goes to 1, and we simply obtain this EV to be exactly this difference between those 2 points. Okay, so that'll be the EV. Okay, and similarly, we'll have this illustration of the CV. Okay, so again, the starting point will be this P0 with this old bundle. Okay, so this is the old price P0. And after the price change, and the price dropped from P0 to P1, and we have P1 and this new bundle here. Okay, so in the CV, what we are looking for is the difference of the expenditures. Okay, but we have those 2 different expenditures. One of those is to reach the unity level of U1. Okay, that'll be this indifference curve, and the other one will be the old utility U0. Okay, that'll be this indifference curve, but we have to put the new prices in the computations of the CV, because CV, by definition, CV needs to have the new prices. Both 2 prices have to be P1 at the same time. So again, we simply shift this line. Okay, we shift that parallel to here to be tangent to this U0. Okay, in this case, we can obtain those 2 intercepts as before. Okay, so the one on the top here, it'll be this intercept will be the level of the expenditure where we have this new price P1 and the new utility U1, and the intercept at lower, that'll be the expenditure with the new price P1, again the new price, but with the old utility U0, and both 2 divided by P2. And again, if you normalize that to P2 to be 1, and this distance, that'll be exactly the CV. Okay, good. So those 2 figures will be very helpful for us to further understand the basic intuition behind the CV and EV, right? So there will be another alternative representation of CV and EV, okay, but it'll be using the integrals of the Hickson domains, okay, and this will be also very useful and very intuitive for us to understand those further. Okay, so let's have a look on the EV first. So by the definition, so EV will be the difference, so those 2 are the same thing. So that'll be the difference of the expenditures where we are using this this utility of new utility with old price to minus W. Okay, so essentially what we are having, okay, what we are having here, because recall that the when we're taking the partial derivative the expenditure function with respect to the price, then we can simply obtain the Hickson demand. Okay, so that was some result that we have already mentioned previously. So in the other way around, if we take the integral of the Hickson demand with respect to the price, and then we can simply obtain the expenditures, right? Okay, so, and from here, this difference between those two expenditures with P0U1 and P1U1, and that'll be exactly this integral from P11 to P10. And that's the integration of this H1, taking P1, P minus 1 bar, and U prime. Okay, and with respect to the P1. Okay, so this P1 bar will be just the vector for all the other fixed prices, for all the other commodities. Okay, so similarly, we can also use a figure to illustrate this EV using the integral representations. Okay, so here we have this space, but this is x1, but here we will have this as p1, but not x2 on the vertical axis. So first, we draw those curves for the worth and demand. This would be the x1, taking p1, p minus 1 bar and w, and also we will have those curves as the Hickson demands, which are the p1, h1, p1, p minus 1 bar, u0 for the first one, and u1 for the second one, Hickson demand. Okay. All right, so at the intersections, we have those prices, P10 and P11, and those consumption set X1 with P0 and P1. Okay, so if you have a closer look on this picture, and you immediately observe that the area under this H1, taking this U1, this curve, that'll be exactly this area, right? So this shaded area, and that'll be exactly the integral of this H function, and taking the U1 as this utility level. Okay, so the boundaries will be from P11 and up to P10. Okay, that'll be a very interesting interpretation. So similarly, and we'll just skip the steps for deriving the CV. So correspondingly, CV can be represented also by the Hickson demands. But here on the picture, the area that is under the H1 function taking U0, that'll be this function under this curve. So that'll be this area. Okay, so this shaded area, that'll be the integral to obtain this CV. Okay, good. So, and as we can see, this integral representation, that would be also very useful for us to further understand the intuition of the CV and EV, right? Okay, so and we mentioned in the beginning that sometimes CV is bigger than EV, and sometimes it's the other way around, and sometimes they're equal to each other. So essentially, for a normal good, okay, EV will be bigger than, strictly greater than CV. Okay, for the inferior good, we're talking about the price change for the P1. Okay, so for the inferior good, and it'll be another way around, so CV will be smaller, and if there's no wealth effect, and those two will be the same. And you can have a look on the textbook or you can try it by yourself to further prove this, and there will be no difficulty through this. But for the last point, so if there is no wealth effect, then we simply have all those Hickson demands and Orson demands, taking the P1 and P1 bar, P1 minus P minus 1 bar, and no matter is U0 or U1, and also the Orson demand with W, they're all the same in this case. Therefore, the area under those curves, they're exactly the same, and there will be no difference between the CV and EV in this case. Okay, good. And so that'll be everything about those different variations in the welfare analysis. So later we'll also talk about some other interesting results in the welfare theory.